Okay, IBSL1, I'm back with a quick video for you guys because during our first introductory lesson to the binomial theorem, we learned about this, nCr, but we didn't really talk about its connection to Pascal's triangle. We just learned how to do it. So Ms. Railsback kind of went over some stuff yesterday with you, but I thought just one quick video to kind of tie it all together. So here's Pascal's triangle. It's a triangle. Some dude named Pascal found it. He found it in the woods one day. We know how to make it. You always take like the two terms above each number and add them together to get the next one down. So it's the one right above to the left and above to the right. So you always add these together, and you always put fresh ones on the outside. Now, the reason that Pascal's triangle is important to this unit is because these numbers are the coefficients of these binomial expansions. So let's remember that this top line are the coefficients of, I'm going to use a and b today instead of x and y. A and b to the 0, a plus b, excuse me. This is a plus b to the 1. This is a plus b squared, etc. This would be a plus b cubed. So it's like the top row is the 0th, and the second row is the first, and like, yeah. Also a quick note on all these, like, let me see here. What are we up to? 3. So this would be like 4, 5, 6, 7, 8. So this line would be the coefficients of a plus b to the 8th power, but this would be the coefficient of the first term, and this would be the coefficient of the second, and this would be the coefficient of the third, ... Now, there will be problems coming at you guys where they may ask you about, like, you know, a plus b to the 30th or something, which means that it would be very annoying to make a Pascal's triangle all the way up to the 30th row. So the big connection that we didn't get to, each of these numbers is findable using nCr. So another way to write Pascal's triangle is that the top is like, am I zoomed in enough? 0, choose 0, and then the next two numbers are 1, choose 0, and 1, choose 1, and then the next row would be 2, choose 0, 2, choose 1, 2, choose 2. Then the third row, or 1, 2, 3, no, the fourth row would be 3, choose 0, 3, choose 1, 3, choose 2, 3, choose 3. Like each of these, you can use the formula or your calculator, which we posted a video on how to do it quickly with your calculator. Each of these are a number when you crunch 3, choose 3, like 3 factorial over 3 factorial times 3 minus 3 factorial. It's a number, and it's a number in Pascal's triangle. So the next row, it would just keep going like this. 4, choose 0, 4, choose 1, 4, choose 2, 4, choose 3, and 4, choose 4. A quick note about this that everybody gets tripped up on, like a classic trick question, is that this first term right here, this is the first term. Notice that it's not 4, choose 1. That's always where people get tripped up, where I say, hey, find me the third term in this sequence. And people would be like, okay, I got to do n choose 3. Well, no, n choose 3 is not the third term. In fact, if you use 3 as your bottom number, it's like 1, 2, 3, 4. So 4 choose 3 is actually the fourth term in x plus y to the fourth. Or it's the coefficient of the fourth term. So notice that this number is always one behind of the term that you're looking for. First term is 0, second term is 1, third term is 2, fourth term is 3. Here's the formula for it. You can use the formula. That's fine. It always works. Or you can use that nCr button on your math button on your calculator, arrow over to probability, use the nCr. Now, let me show you how you can put this all together. What is the fourth term in m minus 3 to the 20th? Now, we don't know the coefficient of the fourth term in the 20th expansion. So you could make your Pascal's triangle all the way up to the 21st row. Remember that it's one behind there as well. Or you could just use nCr, but you got to use it pretty strategically. And remember that point I told you about it always being a little behind. So according to the binomial theorem, which if you're like wondering what is the binomial theorem, the binomial theorem is just each term in an expansion looks like this. The coefficient, that's not right. The coefficient is from nCr, or Pascal's triangle. Then each front term is like, you know, to a bigger power, but then they descend by r every single time, and then the back term grows. So like the relationship between this power and this power is as r gets bigger, like, you know, the back term gets bigger and the front term gets smaller. So this is why the binomial theorem has like the front part powers descending and the back part powers ascending. Sorry, that was kind of rambly, but yeah, it works. Okay, let's plug it into the binomial theorem. If we want the fourth term in the 20th expansion, so the 20 is just going to be 20, but we're going to have to do 20 comma 3. This part right here is for the fourth term coefficient in Pascal's triangle without actually making Pascal's triangle. Then the a in this case would be equal to m, and this will be to the 20 take away 3. Wait, 20 take away 3 or 20 take away 4? Hold on, the first term. Yeah, that's right, 20 take away 3. And then the next part would be negative 3 to the power of 3. Now, using my calculator, I'm going to figure out what 20 choose 3 is. So 20 math, probability, go down to nCr, and then punch 3. So this whole number here is 1140. Now, here, this is 17, so this becomes m to the 17th. And then this whole part, negative 3 cubed, is what? Negative 27, I believe? So then, all I really have to do is multiply this number and this number together. So the fourth term in that expansion is going to be negative 30780 times m to the 17th. And then we are done. Okay, guys, there's the connection to Pascal's triangle. Yeah, a lot of parts with the binomial theorem.